First question. Let A equal this set 1, 2, and then decide if each of these is true or false, and explain why. So essentially this is asking about the power set of A, so let's go ahead and just write that out. The power set is defined as the set containing all of the possible subsets of the original set. So this would be, in this case, the empty set, because that always is going to be an element of the power set. And then the set containing 1, the set containing 2, and then also the set containing 1, 2. So then the first part, is A an element of the power set of A? Well, this last item here actually happens to be A. So this first part would be true. The second part, is A subset of the power set of A? Well, this actually is false, because A does not contain the same elements as the power set of A. If this were to be true, then we would need to see something like the set containing A to be in the power set, which is not the case. For number 2, so number 2 is to come up with open sentences P and Q where the following properties are the case. For all x and z, that is for every integer, P of x implies Q of x is false. But also, there exists some x and z, that is, there exists some integers, such that P of x implies Q of x is true. So with implications, let's just remember what the truth table looks like. So true, true, false, false, true, false, true, false. And then basically, this will be true when they're both true, or when P is false. Otherwise, if P is true, Q is false, it's false. So what we're looking for here, I'll go ahead and just write it out, but the open sentences I'm going to choose are P of x is even, and then Q of x is composite. The reason this works is because if we say x is even, so looking at the integers, all the even integers, if it's even, and then when it's also composite, that is not always the case. I can think of specifically one example where x is even but not composite, and that's the number 2. So this would be false. However, I can think of basically every other even number would fit the second part where it's even and it's composite. So that means there exists at least one x for this to be true. For question number 3, so we have this English statement: at the restaurant she ordered fries or chips. And so we want to basically distinguish what or would look like if we're just talking like in normal English, and then also what or would look like if we're talking like a logical sense. So of course the main thing is if we're talking in normal English, we're usually doing something using the exclusive version of it, which kind of translates to either. So in this case, we would be saying that she either ordered fries or chips, but not both. Whereas in logic, it could be fries, chips, or both. So in logic, or basically just one of them has to be true, or both. So that's essentially the difference between a exclusive and an inclusive or.